Good day, students. Today, I just want to help you through a question which came sometime in 2012. It was a stoichiometry question involving the production of sulfur dioxide. Now, in the lab, if you want to produce sulfur dioxide, you can actually take sodium sulfite plus hydrochloric acid, and then you make sodium chloride, sulfur dioxide, and water. Okay, that's one method of producing sulfur dioxide in the lab. Okay, so in this, whenever you're doing chemical reactions in the lab, one of them has to be in excess. Okay, so that one which is not in excess is going to govern, is going to be the limiting factor. The HCl in this case is in excess, so we don't use it for calculation because it's in excess. It's going to be present, okay, at the end of the reaction anyway. The word excess, sometimes the examiner is asking that. The word excess means it's more than the required amount. So HCl at the end of the reaction, it will still be there. So whenever we are doing stoichiometry, we don't concentrate on the excess reagent. We concentrate on the limiting reagent. And in this case, we have HCl. So this one is in excess. So we are going to concentrate on our sodium sulfite and sulfur dioxide, okay? We are going to relate how much sulfur dioxide is going to be produced when we use a certain amount of sodium sulfide, okay? This equation is balanced. Because it's balanced, we can use it for calculations. What information do we get from this equation? From this equation, we are saying whenever we use 1 mole of sodium sulfide, we are going to get 1 mole of sulfur dioxide. That is fixed according to a balanced chemical reaction, okay? 1 mole of sodium sulfide will always give me 1 mole of sulfur dioxide, okay? So in this case, we are given 3.15 grams of sodium sulfide, okay? So what we do first, okay? What we need to find out first, we need to find out the number of moles of sodium sulfide, okay? Number of moles of sodium sulfide, we are going to use this formula, mass given over the mR for sodium sulfide. The mass given for sodium sulfide is 3.15, okay? The mR for sodium sulfide is 1.26. And then we find the number of moles there. If we do our calculations, we are going to get 0.025, okay? We're going to have 0.025 moles of sodium sulfide. But according to our chemical reaction, the ratio is 1 mole sodium sulfide will always give you 1 mole of sulfur dioxide. So from the equation, you're going to get that the number of moles of sulfur dioxide is also going to be equal to 0.025 because stoichiometry is fixed here. 1 mole sodium sulfide will give you 1 mole sulfur dioxide, okay? But we want the volume, okay, of sulfur dioxide produced at RTP, right? So volume of sulfur dioxide, remember the formula for calculating volume is going to be number of moles multiplied by molar gas volume. And it says RTP. So it's going to be 0.025 multiplied by molar gas volume at RTP is going to be 24, okay? When you do your calculations here, you're going to get 0.025 multiplied by 24. This will give you 0.6 dm cubed, okay? So this will be the answer, the volume of sulfur dioxide that is produced. I hope I've managed to help you to understand, to go through this very simple stoichiometry to understand how we can determine the maximum volume of sulfur dioxide that is going to be produced when we react sodium sulfide and HCl. Remember, in chemical reactions, whenever we say excess, don't concentrate on the excess because that one will not limit the reaction. It will still be present after the reaction has gone to completion. Excess is just there to ensure that we use up all the sodium sulfide that is present. Because remember, the word excess means more than what is required. I hope I've managed to help someone somewhere out there to understand basics of stoichiometry. Have a good day.